welcome to my class. If you need to contact me, I can be reached at the above email address here, pascalclass@heyman.us, and I do have a help files on a website at this web address, heyman.us/pascalclass/associated.html. If you have any questions about the content, you can always reach me there. We are going to start looking at continuation of MySQL, but not exactly. We're going to be covering some additional concepts that you may want to be using. This is a program that produces a regular report, and it has a heading in it, and right here this does connect to an SQL server, and it does just select some basic information and produces a report. In there I produce a heading, which I'm using basically 2 lines to basically put names on the columns. The problem is when we reach a certain number of lines, we want to produce a new heading with a new page number. There's a problem in doing this. It is considered by some to be bad form, at least bad form, to repeat the same code over and over in a single program. One author I appreciate reading states that you need to refactor it into a subroutine. And let me quote what he said exactly. This is Pete Goodlife in his book, Becoming a Better Programmer, and he said, "Unnecessary code duplication is evil. We mostly see this crime perpetrated through the application of cut and paste programming. When a lazy programmer chooses not to factor repeated code sections into a common procedure or function, but physically copies from one place to another in their editor. Sloppy. The sin is compounded when the code is pasted with minor changes. When you duplicate code, you hide the repeated structure and you copy all the existing bugs. Even if you repair one instance of the code, there will be a queue of identical bugs to bite you another day." In this quote, I changed, he just used the word functions because he was talking mostly about the C language, and C language has functions, while Pascal has both procedures and functions, and we will discuss both. To fix this problem and make it into a common routine, well, first of all, I should probably let you know that this does work. And I can show you that. There is the heading routine. and all seems to work correctly, but we do have the problem of repeating the code. If we move along to example 17, we have a procedure here with the source code in it. Whenever you declare a procedure, the word procedure is first, followed by the name of the procedure, and a semicolon. In here you can have variables that you want to pass, and we will be talking about that. But a procedure has its own begin and end. The end ends with a semicolon, not a period. It's almost like a small program within our program. And then you have basic standard Passcal statements. Anything that was declared up in the primary variable section is accessible within our procedure. Those are called global variables, and they are accessible. We can update them, and everything is okay to do such. But it is often considered better to just be modifying local variables, because we can declare variables right under the procedure name line. But I will be getting to that in a little bit. And then down here, we can just call headings right here, which is the name of the procedure, and it will execute. We also have it up here. And basically, we replaced 4 lines of code with just one in the main routine, and we just separate it, and it's easier to maintain. If we need to fix something, we fix it in one place, and we don't have to fix it in both places. And it is clear to someone reading the code what is going on. And I can show you this works just as well as what we had before. And actually, the compile is no longer. This works just as well as what we had before. Now, in the next example, I'm just improving a little bit by passing page number, which is an integer, to the procedure. Page number is actually declared here, but in the when we call headings now, we include in parentheses the page number, which is defined within the procedure as an integer. Now, if we had called this something else, we could, as long as it's an integer, we can pass it up there. So you can use this with multiple different types of variables or different variables as long as they're integers. There's a problem with what I have done here, though. If we try to do this and compile and run it, it will compile, and it will run. But the page number isn't incrementing. It's still 1 here. What happened is when we passed this page number in, what we passed is a copy of integer. It's not the actual piece of data that's up there. It is just a copy of it. If we go and put the word var in the definition up here of integer, it will pass it as a pointer. It'll work just like C does, where they pass variables as with a pointer to a type. That's what's happening in the background. But as far as the programming goes, we don't treat it any differently. And this actually makes the coding easier. You just have to remember to put the word var in front of it. And in this case, the page number is incrementing. Because if we don't put that var there, it will only change within the procedure itself. But once you exit the procedure, the change is lost. So procedures, we do use them with headings a lot. We do use it in other places. Going back to example 12a, where we are inserting data. but we're reading the data initially from a text file, which is a CSV in this case. This is the program where we inserted state information into a basic table. Now let's go out to that database. And I called that database, well, that's not the one I want to use, but it's okay. Okay, when we open that data, there is a problem that occurs. When it reaches the last record, it will flag it as an end of file, and that last record is not processed. So in order to process the last record, beforehand I had an extra line at the bottom like so, and it would hit an end of file on a new line. But you can't guarantee that being in a CSV, especially when you're downloading off the internet or it has been sent to you. It's probably not going to have that. And so we need to process that last record after the loop is done. And the best way to do that is, well, you could take all this information here. You could do what Pete said not to do. You can put additional set of code right down there. But that's bad programming, and it's at least considered bad programming form. It is much better to come up here and turn it into a procedure. We put the word procedure. And let's just call it process data. We need a begin and an end. And we can put our block of code in here and everything will be okay. And Even better, we could take our state name, state code, query, and all of that, and use local variables. But just to get the idea across, we don't have to do that. Then we could come and just remove all of this. And our global variables will work. And we'll want to save this. I'm going to save it to another name. I'm going to save it to D. Or not. Save it as 12 improved. Now, if we come back here, and I can show you that the previous one isn't going to get the last state in. Now, if we come over here and do a select, you can see Wyoming is not there. But if we go back, and it's not finding it. And Wyoming is back in our data set now. So in order to get the last record processed, it helps to break the data down And procedurize it. Put the process data. And actually, this should not be there, but since we did the commit up in the procedure. So that's another place where you would find using a procedure would help in your Pascal programs. Now, Pascal has another type of little sub-program that's called functions. Now, C only has functions, which basically include both procedures and functions. But Pascal had separated it originally. And functions are basically used when you don't need to update the information, but you need to calculate something. And basically, you have to declare it as a function. You have to declare the name, and usually you're going to pass something to it. But after the quotes or the parentheses, you're going to put a colon and tell what type of variable we're going to return. And in Pascal, you can return a variable in one of two different ways inside the function. You can take the function name and return a value to it, or you can just use the word return and then the variable you want to return. And then down in your code, you can take in this case it's a double. A double receives the value. And it's just like an assignment. And you just do a colon equals and then the function name and the input. The input name has to be of the same type as declared in the function, but it need not be the same name. So you can then reuse the same function in multiple places with different variable names, but they all have to be of the same type. And in this one, we have declared two functions. One is length in inch. It takes centimeters and converts it to inches, which is centimeters divided by 2.54, and return it as an inch. And in here we convert inches to centimeters by multiplying by 2.54 and returning the centimeters. And I can show this works. I have introduced a bug. just a typo. And in here we are, the logic is it first displays our message. With the message procedure. Right here, and then if we do C, and then we say 20. No, use 8. And that should give us 20. Slightly more, but I happen to know an 8-inch telescope is worth 20 centimeters. And we can do the opposite. And that's 8 inches. So the functions do work. Now the functions can be of multiple different types. You can declare a function of a char, your different types of integers, your different types of floats and strings. And you can also create complex types using the type statement, which I am not going to discuss here. If you want to know how to do that, you can write to me. We can do more with this. In example 21 here, we're converting from Celsius to Fahrenheit and back. So if you say Fahrenheit of 80 degrees, we should get an equivalent Celsius temperature. No, I did that wrong. Which is, they're saying, is 26.67. And 25 is approximately 77 degrees comfortable. So you can use functions to break down calculations and keep them out of the main loop, so that the main loop becomes clearer as to what you're trying to do. And functions can call other functions too. In this, I am converting cubic inches to liters and liters back to cubic inches. And I reused conversion of inches to centimeters and centimeters to inches, and I put that within the routine, the functions to convert liters to cubic inches and vice versa. Basically, a liter is 1,000 cubic centimeters. And I'm using a little bit of math here, using the log function. You could use the power function instead if you're more comfortable with that. And in here we talk about some cars from the 1970s and converting them, which were in cubic inches, to the more common liters today. So let's take the Chevy Malibu, which had a 250 cubic inch engine. And 250 cubic inch engine would be equivalent to 4.1 liters, which would be a considerably large engine by today's standards. And you could take today, a large or a mid-sized car might have a 2.5 liter engine. Which equivalents to only about 153 cubic inches. So this does work, and it is useful. Now I would like to go back to (18B), where we're doing this minus 20, minus 30, minus 7, minus 17. We can pad with a function. So we could declare a function in here of pad, and let's say it is a string, and we're going to declare a variable L of an integer. Oh, I'll make it a long int. It doesn't matter. And we're going to return a string. We'll have a begin and an end. And we're going to declare a local variable within this function of I, maybe a couple of others. And what we want to do is we want to create a padding function. The L is coming from the declaration of the function, the second variable. We're going to say I equals L2 or equals length of our string to L do and S equals S plus a space. And then we want to return or say pad equals S. Now we're going to want to save this as we already have an 18.c, so I'm going to make it an E, or 18 improved. And in here we could say, instead of messing with this 20s and 30s, we could just make this just an S. And then we could pass our first name comma 20, and this should work. And you could put pads down here down here instead of using that, but just to let you know that this is a possibility. I may have messed up the name. Just a simple error. And the heading are kind of working, but what I changed had no effect, well, a minor effect. I had one longer than what necessary, but it will work. And in this case, just change this to a -1 and it will work correctly. And there it is lining up correctly. So functions are a powerful tool. And this comes up in something I want to talk about. When you are importing data from a CSV, if you look at the data that comes in, you may not be guaranteed that every column will have data in it. And if you have the separator, which in this case commas are the separator, if you have several commas rammed together, like right here, extract word will not handle that correctly. and it will only work correctly if you put a space between the separator character, in this case commas. And I have used a function to do that. So I have named the function fix buffer, and in this I go backwards, and to go backwards in a for loop you can use the down to instead of the to. So we're starting at the length of the string and we're saying down to 1. I compare for 2 commas in a line. I use the copy statement, which will just take a section of your string, starting with the string, starting at I for a length of 2. If it equals 2 commas together, then I'm going to insert a space between them. And I'm doing it down to because it would change the length of the string every time you insert a character. And this way, going backwards, it won't change the outcome every time you insert a space. And then I return the string to fix buffer. And before I try my extract word, I run the fix buffer on the buffer, returning it to buffer. This will work. It will work here. I'm not going to go through it here. I'm not going to run it here, but because this is a very fairly long-running process, and I don't want to clog it up, but this is something that we have to do with CSVs, because CSVs often have just a bunch of separators rammed together, especially if I'm using LibreOffice to extract out of an Excel spreadsheet into a CSV. That happens a lot, and I suspect it would happen with Excel also. Again, if you have any questions, you can write to me. And I can be reached at this address. Thank you.